you can quickly simplify this expression to an integer, then this video is unlikely to be a revelatory experience for you. But if the sight of it causes you weeping and gnashing of teeth, then stick around, because today we're going to unveil the sacred laws of the mathematical gods, the 10 Commandments of Exponents.
1. Thou shalt multiply exponents when raising a power to a power.
X to the a to the b is equal to x to the ab. For example, x squared cubed is x to the 6th, not x to the 8th. Let's unpack this notation to build some intuition on this. X squared cubed is x times x times x times x times x times x, which is x to the 6th.
2. Thou shalt use fractional exponents for roots.
The 8th root of x to the b is x to the b over a. The square root of x is defined as x to the 1/2 power. That's a notation that you just need to accept on faith. Similarly, the cube root of x is defined as x to the 1/3 power, and so on. If we had the cube root of x squared, that would be x squared raised to the 1/3 power, which is x to the 2/3 because stacked exponents get multiplied. And so in general, think x to the power over root.
3. Thou shalt add exponents when multiplying like bases.
X to the a times x to the b is equal to x to the a plus b. For example, x squared times x cubed is x to the 5th, not x to the 6th. If it's not obvious why, then let's unpack this notation as well. X squared times x cubed is x times x times x times x times x, which is x to the 5th. Where people tend to stray from the flock here is a case like x times root x. To write this as x to some power, we would say x to the 1st times x to the 1/2 is x to the 3/2.
4. Thou shalt subtract exponents when dividing like bases.
X to the b over x to the a is equal to x to the b minus a. To build some intuition behind this, notice that if we have x to the 5th divided by x squared, two pairs of x's cancel, leaving x cubed, which is x to the 5 minus 2.
5. Thou shalt combine like terms.
X to the a plus x to the a is equal to 2x to the a. If you have something like x cubed plus x cubed, that's 2x cubed. Not x to the 6th, and not 2x to the 6th. Don't mess with those exponents, just combine like terms.
6. Honor negative exponents as reciprocals.
X to the negative a is equal to 1 over x to the a. For example, 3 to the negative 1 is 1/3, not negative 3. Negative exponents do not mean negative quantities, they mean fractions. 2 to the negative 4 is 1 over 2 to the 4th, or 1/16. This is where exponent rules get a little abstract, so some of you will appreciate a quick argument for why this rule makes sense. Notice that 1 is equal to x over x, which is x to the 1 minus 1, or x to the 0, which shows that x to the 0 is equal to 1. Using that result, we have that 1 over x to the a is equal to x to the 0 over x to the a, which is x to the 0 minus a, or x to the negative a. This shows that 1 over x to the a is x to the negative a.
7. Remember to distribute thy exponents across multiplication, to keep them holy.
ab to the n is equal to a to the n times b to the n. Most often this comes into play when n is equal to 1/2. The square root of ab is ab to the 1/2, which is a to the 1/2 times b to the 1/2, which is root a times root b. This tells us that we can break radicals across multiplication.
8. Thou shalt distribute thy exponents across division.
A over b to the n is a to the n over b to the n. Again, this comes into play most often when n is 1/2. The square root of a over b is a over b to the 1/2, which is a to the 1/2 over b to the 1/2, which is root a over root b. Let not divisiveness stand in thy path. You can break radicals across division.
9. Thou shalt not distribute thy exponents across addition.
A plus b to the n does not equal a to the n plus b to the n. For example, notice that a plus b squared does not equal a squared plus b squared. Thou shalt FOIL. If you multiply out a plus b squared, you get a squared plus 2ab plus b squared. A lot of you also commit the sin of breaking radicals across addition. The square root of a squared plus b squared does not equal a plus b. I know a lot of you want to try to reduce this, but it's forbidden. Leave it alone.
10. Thou shalt not distribute thy exponents across subtraction.
a minus b to the n does not equal a to the n minus b to the n. Subtraction works the same way as addition. The square root of a squared minus b squared does not equal a minus b. I know you've done this before, so repent your wicked ways and leave this radical alone too. You cannot reduce it. With these rules under our belts, let's try the opening problem. The 9, the 3, and the 27 can all be expressed in terms of a common base, namely 3. So that gives us 3 squared to the 3x plus 1 in the numerator, and 3 times 3 cubed to the 2x in the denominator. We then have 3 to the 6x plus 2 over 3 times 3 to the 6x. Simplifying the denominator, we get 3 to the 6x plus 2 over 3 to the 6x plus 1. And finally, we can subtract the exponents to get 3 to the 6x plus 2 minus 6x plus 1, which is just 3. Now that you've made your exponents wholly again, check out my practice problem walkthrough video on exponents and radicals here.
Now go forth and multiply.